horizontal asymptotes. Now, if you know about vertical asymptotes, horizontal are similar, but a little bit different. Now, horizontal asymptotes simply mean if we are graphing, if we have a horizontal asymptote, it's a horizontal line that our graph will approach, but never touch. Now, there is one time where that is actually a false statement, and that happens when our horizontal asymptote is the x-axis. So if we have a horizontal asymptote at y equals 0, it is possible that if you have an x-intercept, that the graph can cross at that spot. So that is one thing. Normally, a horizontal asymptote, the line approaches but never touches unless you have an x-intercept. Okay, just throwing that out there that sometimes that does happen. So just be aware that it is possible. Okay, now horizontal asymptotes are based off of the degree of the numerator and the degree of the denominator. So we want to compare those. If the degree of the numerator is less than the degree of the denominator, so maybe we would have x over x squared plus 1. You can see that the degree of this numerator is 1, the degree of the denominator is 2. Therefore, the numerator degree is less than the degree of the denominator, so the asymptote is just y equals 0. That is kind of a straight, nice and easy, it's y equals 0. Second piece, if the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is the ratio of the leading coefficients. For example, if I would have 2x plus 4 over 3x minus 1, we can see that degree 1 in the top, degree 1 in the bottom. So the ratio of my leading coefficients is 2 over 3, and so y equals 2 over 3 would be my horizontal asymptote. Okay. And then the last one, if the degree of the numerator is exactly 1 more than the degree of the denominator, you have no horizontal asymptote, but you do have an oblique. So if we had x squared plus 2 over x minus 3, you can see we would have degree 2 in the top, degree 1 in the bottom, and therefore we would have an oblique asymptote. We will get to that in a different video. So let's look at a couple of examples. We want to determine and find any horizontal asymptote. So when you're doing this, you want to say, okay, I need to recognize the degree. So I can see pretty easily in the numerator that this is degree 1. In the denominator, if you can't tell by looking, go ahead and expand it out. If I take x plus 3 times x plus 7, I get x squared plus 7x plus 3x plus 21, which is the same as x squared plus 10x plus 21. Well, because of the x squared, that's degree 2. So because the degree of my numerator is less than the degree of my denominator, my horizontal asymptote is y equals 0. Let's do another one. If I have the function f of x equals 3x squared minus 4x plus 6 all over 2x squared plus 7x plus 9, well, x squared, degree 2. X squared, degree 2. Since these are the same, we take the leading coefficients. So my horizontal asymptote is going to be y equals 3 over 2. And then here's our last example. You'll notice we have x cubed, degree 3, over x squared, degree 2. Because the numerator is 1 more, we have an oblique asymptote. Okay, so no horizontal. You cannot have a horizontal and an oblique asymptote. It's one or the other. You either have horizontal asymptotes or you have an oblique asymptote. You cannot have both, one or the other. So we will have a different video on how to find oblique asymptotes, but here it's important to recognize degree of the numerator, degree of the denominator. That will lead you to the type, whether it's horizontal or oblique.